Say again.
I said I can see your board clearly since I pinned it.
Oh yeah.
Yeah, can you?
Yeah, just
Yeah, that's fine. Just the board. As long as you can see the board. Yeah.
I can see, yeah.
Okay. Cool. And it's recording here too.
This is why Iris is gone.
Hey guys, everything is wrong. All right. All right. Anyway. So the easiest way to understand rotational motion or angular moment of inertia or angular momentum is just converting everything from linear to rotational. Right? Now since it's still part of mechanics, so everything applies, still applies. Okay? So laws of motion applies, everything applies, including kinematics. Alright? Now, but common problem students, do not confuse rotational motion with circular motion. Okay? Now everything in circular motion is still, everything is still linear. We consider it as a linear function for circular motion. So we have tangential speed or linear speed. We have tangential acceleration. So all those are expressed in linear units. Now unlike angular, so now everything, so your object now, so depending on your object, so it's now spinning in its own axis. Okay? Now it also depends on what kind of object you have. So if it's a cylinder, or a sphere, or a ring, okay, so it varies, okay? But then again, so the easiest way is to convert everything from linear to rotational. Here's how. So linear. Can you see this? Yeah? Then rotational. Rotational. Okay. Alright, so let's do this. Now let's start with your anyone else? Okay. Displacement. Okay. So displacement with or distance, we express this in terms of meters, right? Now for rotational, your distance turns into your theta. Turns to theta. So we measure this in radians. Okay? Now your velocity or speed in meters per second for linear. Now for angular, it turns into omega, expressed in radians per second. Okay? Now this is omega lowercase. Now this is also omega. So that's uppercase. Okay? But we're using this one. Okay? So that's angular velocity or angular speed. Okay? Next we have acceleration. So meter per second square. Now for rotational, it turns into alpha. Fishy sign. In radians per second square. Okay? Now next, mass M. So mass M in kilograms. Okay? Now for rotational motion, so mass M turns into inertial mass, or I, capital letter I. Okay? So we express this in kilogram meter square. Let me double check. Kilogram meter square. Alright? Now this inertial mass, as I've said earlier, depends on your object, your solid object. Okay? Now if it's a sphere, a cylinder, or a ring, and so on. We'll discuss that next week. Okay? So mass, inertial mass, in rotational. Next, force, unbalanced force F. In, right? Or base units, kilogram, meter per second squared, right? So that's your base unit for force. Okay. Now force for rotational motion turns into torque. Okay? So what is your unit for torque? Newton meter for rotational motion. Okay? Then what's next? Momentum. P. So we express momentum, linear momentum in, let's see, okay, in kilogram meter per second. Remember this? So mass times velocity, momentum, linear momentum. Now for angular momentum, so this turns into L. Okay? So angular momentum. So angular momentum, So unit, kilogram, meter square per second. Okay? So this is the basic. So linear to rotational. Okay? Do you follow so far? Anyone lost? Confused? You good?
Mr. G, I can't see it anymore.
Up to which part? Up to which part? Can you see up to here? Force? Up to where can you see the screen, the whiteboard?
M and I.
Right here?
Yeah, right there.
How about the rest? Up to here, everyone? Alright, let me do it again.
I can see everything. Yeah, I can see everything.
You can see everything? So I'll just post this video.
Okay.
We good? So I'm recording it 3 ways. Cool?
Okay, because the video got really
Yeah,
grainy and I just stopped seeing.
that's okay. So I'll post this.
Okay.
So I'll check which one is the best, then I'll post this. Yes?
Okay.
Cool. Let me see on... Yeah, I got everything on my camera. Cool.
Cool.
Alright. Which brings me here. Now again, so everything we have learned in kinematics, linear kinematics, applies to rotational, which means, remember this, V naught plus AT, equation 1. So can I use this for rotational? Yes. So your V turns into what? Omega naught plus alpha t. Okay? dV naught t 1/2 AT squared. So we can translate this to rotational. So this one, theta omega naught t 1/2 alpha t squared. Okay? Then equation 3, v squared, v naught squared plus 2ad. Right? So for rotational, this becomes what? Omega squared, omega naught squared plus 2 alpha theta. Okay? So linear kinematics, rotational kinematics. Okay, so everything else applies. Okay? Now, all right. This one, second law. So what is second law? F equals what? MA, right? Now for rotational, F becomes what? torque, right? Equals mass turns into what? Rotational, inertial mass. Then A turns into what? Alpha. Okay? Then finally, linear momentum is what? mv, right? Now for rotational, so P turns to angular momentum, L. So M turns into what? Inertial mass. Then V turns into what? Omega. So omega. Okay? Hold on. And what else? Alright. Any question up to this point? Be good? So again, so what I did here, so just transform everything in linear to rotational. Then all you need to do is to do the same way to solve problems on linear. So play around with your equation, same with rotational. Okay? Now how about this? How about KE? So what is kinetic energy? 1/2 mv squared, right? So for rotational, it turns into what? 1/2. Your mass turns into what? Inertial mass. Then your V, omega squared. Okay? So unit in, what's your unit for kinetic energy? Joules. In joules. Okay? So what else? Work. What is work? Work is equal to what? Force times distance, right? Now for rotational, what happens here? So F turns into what? Torque. Then your displacement turns into what? Theta. Yeah? See? So unit in joules, 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 joules. Then just play around with your equation depending on the problem. Okay? Let's see.
Mr. Chief,
Yes.
I'm very confused because I came in so late.
Yeah.
Can you describe that again?
That's okay. So I'm recording this 3 ways. I'm going to post the video.
Okay.
Yeah.
And is there a way to like fix your screen quality because I can't read your board?
How did you do it? Iris, how did you do it?
Oh, it's you just a video and then you can see a bigger version of the screen. But it's blurry for me too. But I'm just gonna wait.
Yeah, that's fine. Yeah, I'll just post a video.
Yeah, it's probably just my Wi-Fi connection. I don't know. But
Yeah.
I'll just wait. It's fine.
I think it's clear on my camera. So let's wait.
It's all good. Yeah.
Yeah, it's really blurred.
Yeah, that's okay. So I'll choose the clearest video, then I'll post it. Yeah?
Okay.
And also, yeah, so I'll post everything.
And our assignments are due Friday.
Huh? Yes.
And that's
Then I told him I'm going to post the answers maybe around Wednesday. So you can actually check your work before you turn them in.
sounds good.
Okay.
Yeah, I'm going to post the final answers. Yeah?
Yeah.
Okay, anyone else waiting? Let me check if anyone else is waiting. Alright, very good. Alright.
Wow. Do come right.
Alright. Alright, next. Here's the next one. Alright. This one. Alright. This one. So how to convert linear to rotational and vice versa. Alright? So here's how. So your displacement D. So all you need to do, so whatever is your theta, so multiply it with your radius. Okay? So your theta in radians, multiply it with your radius of your circle. So this one is in meters. This one in radians. Okay? So you can convert it to displacement in meters. Okay? So that's linear to rotational. How about V? So V, so you can expect it's simply omega times what? The radius of your circle. Okay? And how about acceleration A? Simply alpha times the radius. Okay? So this is very useful. Now of course, radians. So you're going to see this on the problems I gave you. One revolution is what? 2 pi radians. So 1 rev. Okay? Alright, let's see. Okay. Questions? So again, it's a subset, so just like linear kinematics, just play around with your equations. Okay? Be good. Anyone lost? Confused? Yeah? Now, if you're going to check your Canvas, so I republished weeks 1 through 4. So if you need to go back to our my old notes, old assignments, so you can access it. So I republished everything. Now later on, so I'm going to republish even the old quizzes with the answers. Questions? Actually, this is all I have for today. Hoping with this is so you can start or you can attempt working on the problems I gave you. So by Wednesday, I'll solve them today. Hopefully by as early as tomorrow, Wednesday, I can give you the final answers. So you can check. Cool. Let's see. It's recording.